Hello, we're Team Ranch, and our project is on investigating marijuana arrests in Los Angeles, California. We created several logistic regression models to predict the type of an arrest, whether it's a felony or a misdemeanor, based on the gender and age of the individual arrested.
So our research question was, how does the gender and age of an individual in Los Angeles, California affect the type of marijuana arrest charge? And we used data from LA Open Data and the Los Angeles Police Department from 2010 to 2019. And our main goal was to examine potential biases for both age and sex regarding type of marijuana arrest charge and look at severity of crimes in general based on age and sex. So by exploring this relationship, we wanted to identify patterns that could suggest systemic biases or trends in law enforcement practices. Our raw data frame had 16 columns and about 24,000 rows, and we focused on the above variables and cleaned up the variables to use them for data analysis. There are many codes in arrest type code, but we narrowed it down to felony and misdemeanor, which represented a large majority of the data. And we filtered for only these two observations. We made gender into a binary variable with two levels for M and F, male and female.
We performed exploratory data analysis to choose what outcome variable to use and to narrow down the possible observations to only the most common ones under arrest type code, which were felony and misdemeanor. They were also chosen because the two levels are opposite of the severity of the crime. Misdemeanor is not a severe crime, but a felony is a severe crime. Logistic regression was used by us because it is a binary categorical variable and was used to predict the outcome variable, which is charge type. Age and sex were chosen as the predictors of the logistic regression model. They would be predicting whether, based on the gender and age of the individual, if the perpetrator would be more likely to commit a felony or a misdemeanor. Age was chosen because, as shown by the figure on the left, the median age for a committed felony is around 30 years old, while the median age for a committed misdemeanor is around 24 years old. This shows how older individuals are more likely to commit felonies than younger individuals, which is why age was chosen as a predictor. Sex was chosen as a predictor because, as shown on the graph on the right, there was a noticeable increase in the proportion of females that committed misdemeanors compared to the proportion of females that committed felonies. Logistic regression models were created from the training data. A model was created for age as a single predictor, gender as a single predictor, and an additive model and an interaction model between the age and sex of the perpetrator were created as well. The four models were used to predict the outcomes on the testing data set. The false negatives and the false positive rates, the receiver operating characteristic, ROC curve, and the area under the ROC curve of all the models will be compared to determine what the best model is.
These are the results for each model. All of the models appear to have a high rate of false positives, or predicting misdemeanors. All models poorly predict arrest code. As shown on the ROC graph, they all fall just above the dotted line, which means they're only slightly better at predicting arrest code than chance. When looking at the AUC values, the area under the curve for the age model is 0.63, the gender model is 0.51, the additive gender and age model is 0.62, and the interaction gender and age model is also 0.62.
As seen in the confusion rates, the ROC curves, and the areas under the ROC curves, our statistical analysis showed that age and gender are not strong predictors of whether a marijuana-related arrest charge is a felony or misdemeanor. This is because there were significantly more misdemeanors than felonies in our training dataset, so that the false positive rates were very high when the models were used to predict on the testing dataset. This data bias impacted the performance of our predicted models, and in this real-world setting, it led to underreporting of felonies and misclassification of crimes into misdemeanors. That's it for our presentation. Thank you for watching.